Solving equations is one of the main things that we do in math. And we need to start by learning how to solve one-step equations because that gives you the principles for what you're going to do as the equations get larger. So the main rule of a one-step equation or any equation is that in order to move a term to the other side of the equal sign, we have to do the opposite operation to both sides. So first we need to talk about what the opposite operations are. So if we have an addition operation, the opposite is going to be a subtraction operation, which means that if we have a subtraction operation, the opposite is going to be addition. For multiplication, the opposite is going to be division, which means that division's opposite operation is going to be multiplication. Now, there are also operations like an exponent. So if we have a term squared, so for example, x squared, the opposite operation would be to take the square root, which means that if we take a square root, our opposite operation would be to square it. We're not going to do a whole lot with square roots and squares, but it's a good thing to know that those things are also opposite of each other. So if I have a one-step equation that has addition in it, so x plus 2 equals 7, then at the point we're at, we automatically know what the answer is. We wouldn't have to show how we found it. But it's important in the early stages of solving that you show how you got your answer, even if you could do it in your head. So in order for me to solve x plus 2 equals 7, the opposite of plus is minus. So I am going to take that plus 2 and instead I'm going to cancel it out from the left side by doing the opposite operation, or zero it out. But in order to keep the equation equal, as the equal sign says that it is, I need to do the same subtract 2 on the other side of the equation. And many people will draw basically a fence that goes down that shows where the equal sign is, which is a great thing to do when students are first learning, so they can see that you're doing the same thing to both sides of the equal sign. I find it's very important to make sure that you line up the terms underneath the ones that are alike. So I wouldn't put the minus 2 under the x, because that's not what I'm subtracting the 2 from. I'm subtracting the 2 from the positive 2. So now I'm going to go ahead and do these calculations. So this positive 2 and negative 2 cancel each other out because that equals 0. And that just leaves me on the left side with my variable x. And then when I do my calculation for 7 minus 2, that leaves me with 5. So my answer to x plus 2 equals 7 means that x must be 5. And if you wanted to go in and check it, you could plug it back in. And so we would take that 5 and we would write it right here. And we know that 5 plus 2 equals 7. So I'll do examples of the other ones that you'll see. So if we had x minus 3 equals 10, then the opposite of addition, and again, if you wanted to draw that fence, you can. The opposite of subtracting 3 is adding 3. That means that this minus 3 with plus 3 equals 0, which leaves me with just my x variable. And then 10 plus 3 equals 13. If I wanted to check it, I have 13 minus 3 equals 10, and that is true, so I know that I solved it correctly. A multiplication example is important to do because if we have 3x equals, we'll throw some negatives in there, 12. So when we see a number next to the variable, then at this point, this is how we imply that there is multiplication. This is the only one where there's not necessarily going to be a symbol. And so the opposite of multiply is divide. So that means I'm going to divide both sides by 3. And the difference with multiply and divide is that instead of making the value be 0, we are making the value be 1 because we're making it be 1x. So normally when we solve for x, there's that invisible 1 in front of it that says 1x is going to equal this. And that's what we're trying to do here. So 3 divided by 3 is going to equal 1, which means I've got my x. And remember that that means 1x, but we don't have to write the 1, equals. And then my answer to, I don't want to draw that line, my answer to negative 12 divided by 3 is going to be negative 4. So my answer is going to be x equals negative 4. And so our last example, and you don't see this too often, actually there'll be one more. Our last example is going to be divide, and then we'll talk about what happens when there's a fraction. So if we have x divided by 3 equals 2, you can probably also do this one in your head, but again, it's important to learn how to show the steps. So in this case, the opposite of divide means I'm going to multiply. And so I'm going to multiply both sides. And I like to show multiply in parentheses just because then if there's a negative number, it's contained within the parentheses. Parentheses are often used as another way that we show multiplication. We just don't want to use the x because we're using x as our variable. So you'd either want to show a dot or you'd want to put it in parentheses. So this 3 and that this 3 and that 3 become 1. So we have that 1x again. And then 2 times 3, so this part is going to equal 6. So x equals 6 because 6 divided by 3 does equal 2. So the last one we need to talk about is when there are fractions. So if we have 2/3 x equals 6, and we need to solve that. Now, technically this is multiplication, and so you absolutely could divide it by 2/3. But that looks kind of messy and is more challenging to deal with. And if you're putting it into a calculator, it's a little more challenging to do as well. So what we want to remember is what we know. So I'm going to remove all this. We know that when we divide by a fraction, so if we have 6/1, so make that into a fraction, 6/1 divided by 2/3, we know that when we do division of fractions, we do keep, change, flip, which means we would stay at 6/1. We would change this to a multiply, and then we would flip the second fraction. So when we are solving, it is so much easier if we just skip right to the change flip part. And so when I am doing a fraction, I'm going to go ahead and I'm going to multiply both sides by that reciprocal. Remember, that's the math term for a flipped over fraction. And then now it's going to be easier to put into a calculator because you can do 6 parenthesis 3 divided by 2 close parenthesis, or if your calculator has a fraction button, you can do 6 parenthesis, put in the fraction, close the parenthesis. And when we multiply this, then this 2 and this 2 cancel each other out, and that's going to leave you with 1. So now we've got x equals, and then 6 times 3/2 is going to equal 9. Because 3/2 of 9 means that we would multiply the 6 times 3 to get 18, and 18 divided by 2 is 9. So that's how we work with the fractions. Instead of dividing by the fraction, which is much messier, instead we multiply by its reciprocal, and it goes much faster and easier.